Hey, and welcome back to another Revit video. In this video, we're going to look at code, like stair code. Everything you need to know, generally speaking. I'm not a code expert, whatever, but we're going to get to that. We're going to get to the code, the specific, so you know whenever you're not only modeling stairs, but documenting them as well, that you know what to look out for, you know what to take into account, those types of things, you know where to look. So if at any point in this video you happen to learn something, please demolish that like button. It really helps me out a lot. Okay, I will say first, if you haven't watched any of the other stair videos that I've done in this playlist, please do that first because, or if you already have an idea of how to model stairs, cool, that's good. But I'd highly recommend you look at those first because that'll give you an idea of where we are, where we got to, and how we got here, taking into account the code. Now, the first thing I do want to say also is this is for IBC 2018, International Building Code 2018. I am not looking at 21 quite yet because a lot of municipalities have not adopted that. Now, we will in the future have to look at that and take that into account, but this is a fantastic starting point because this, in my opinion, is the most relevant when it comes to stair codes. So what I have here is a list of kind of everything you need to take into account, generally speaking, when it comes to commercial stairs, and we've got diagrams that go along with it. We're going to jump back and forth between this and Revit just so we can see how these things interact and work out together. Okay, so the first thing is actually the definition of a stair. So what is a stair? Well, it is in fact simply as a change in elevation that is consisting of one or more risers. So we're going to get to what a riser is in a minute because that plays into stairs, of course, because obviously, if it's not considered a riser, then it wouldn't be considered a change in elevation or a stair, anything like that. So just be aware of that. Basically, do we have at least one riser? So that's the main thing here. So here we go. The stair components, and this is a diagram that I will blow up because that'll be important to see. Pull this in here, and we can see, look at this. We've got kind of everything labeled out here that you would expect to see from a stair, and that's obviously the riser, the nosing there for our treads, and the stringers are basically the support for the stairs on the sides. This looks to be more of a residential stair, just the way it looks, the way it's shown here. Obviously, we have the handrail that's going up, and then finally our landing. So this is real basic, nothing too crazy here. But we'll go back to our notes here, and the next thing is the max vertical rise per stair run is 12 feet. Basically, that's saying if you have a rise over a continuous stair run that is greater than 12 feet, then you're going to have to cut that off at 12 feet and put an intermediate landing. And then here's a diagram that will show us what that is. And we'll blow this up, and we can see, yeah, we've got 12-foot max for these single stair runs, and then we have these intermediate landings that show up between those 12-foot max. Like that's perfectly fine. It is what it is. And a lot of times this is not going to be an issue until you get to those long straight runs. So not so much to worry about there. Okay. And then we have a minimum of one landing at the top and bottom of each stair run. So what does that mean? Well, that means we have to look more or less at the definition of what a landing is. And we can see that here. Blow this up also. And we can see, hey, we do have a landing here at the bottom, a landing here at the top. And all that means is we have to maintain a minimum width to have it be considered a landing. And in this case, we can look at the next diagram, which will help us out a little bit more. And so this second diagram will show us, if we open this up here, we can see, look, we have our stair width, which is X, and we have yet to determine that, and I will save that for a completely separate video, so we're not going to be talking about stair width at all in this video. That's completely separate. There's a lot that goes into it, so let's just stick with something like this. We have a stair width of X. We have determined what it is. So we need to have obviously a landing. If we're looking at landings in particular, we need to make sure we have at least that stair width. And if that's the case, then we're good. And obviously we need to maintain that stair width throughout the landing itself. And that is regardless of whether or not it is actually a part of the stair or not, hence the top and bottom of our actual stair. Okay, cool. And as you can see here, if we have a switchback stair, which for egress stairs, primarily what we're talking about, you're going to have a case like this. You need to calculate that the center point between the stairs, and you can see you can arc your width around, and so basically you need that width at that one point. Well, and basically what that does is it does translate to a rectangular, more or less, landing, but the clear width, in a sense, the required width is going to be that distance in an arc. Also, do note here that if you have an intermediate landing on a straight stair run, that does not have to exceed 48 inches. So basically, if your stair width is 50 inches, you would not have to have that actually be 50 inches. You could have that be 48 inches instead. So that kind of thing. That's nice to have. Gives us a little more flexibility. Okay, if we look at doors, now this is kind of important because it's basically where you end up placing doors in a stair or on a landing, because typically they're going to be kind of crunched into a landing. So doors opening into a stair cannot reduce the required width by more than 1/2. And so obviously we're not doing the calculation of that width, but just know it cannot exceed, reduce that required width by 1/2 whenever the door is opening. And of course, whenever it's fully opening, we cannot project more than 7 inches into the landing. So we've got two diagrams that will explain this. We have this entire building code section, which is 10.11.6, looking at specifically the stair landings. And it basically says there shall be a floor or landing at the top or bottom of the stair. We've already established that. But if we come down here to doors opening onto a landing shall not reduce the landing to less than 1/2. And then again, whenever it's fully open, the door shall not project more than 7 inches into a landing. Very good. Easy stuff. And then finally, here's our actual diagram, which will give you a better idea of what to expect when you see this. So we have our required width, which is, obviously right there on the stair. If we arc that around, we could see as long as the door opening here, that door swing opening, does not exceed half of the required width, then we're fine. And then obviously the 7 inches here. So imagine you have a door that's fully open. You're obviously going to measure to the inside or the outside of the door furthest to the stair, because that's going to give you the largest number. So basically this point here is where you would be calculating that 7 inches to make sure you are 7 inches or less, that type of a thing. Okay. And then finally we have the min and max tread and riser. All right, looking at this diagram, it will tell you absolutely everything that you need to know. And just note that I have the sections for these. They're all included on these diagrams. So you can go right there in IBC 2018. So we can see here our tread depth, the minimum is 11 inches. All right, that's pretty easy, self-explanatory. And then the max riser height is going to be 7 inches. And the minimum is 4 inches. So this goes all the way back to what is a stair. So a stair is a change in elevation, obviously, but that requires at least one riser. So if we don't have a change in elevation of 4 inches, at least, we don't have a riser. Therefore, we don't have a stair. Now, that's not taking into account tripping hazards or anything like that. So please be aware of things like that. I'm not saying that you don't need handrails or this or that. Like, that's totally separate. We're just talking about stairs here. So obviously, I could have a tread depth that is, let's say, 12 inches if I wanted to. A lot of times you would do that. But typically what I would do is I would have a 7-inch max riser and then 11-inch minimum tread depth. And I would keep that 11-inch minimum because I don't want my stair to grow if too much of it doesn't have to, that kind of a thing. All right, looking here, we have, again, landings, but also the treads. So landings and treads, basically flat walking surfaces, you can only have a max of 2% slope in any direction. And like, this is pretty self-explanatory. This is, if you're familiar with anything ADA, then that's going to be pretty typical. Now, this is not cross slope or anything. This is any direction. So here we go. It's particularly 1 unit vertical to 48 horizontal, or 1 to 48, which is not quite 2%, but it essentially is a 2% slope. So just be aware of that. That's pretty easy to account for, because typically speaking, you're not going to have a egress stair, a switchback egress stair that is going to be subjected to water. So that has primarily to do with watershed. So just be aware of that too. And then finally, we have nosing projection size whenever we look at all these components. So this is a bit important. Doesn't apply to me most of the time because, again, I'm just doing a commercial stairs. We're egressing. That's fairly simple. We've got our riser and tread height, distances, we're already good with that, but you can get a bit creative with some of these riser and nosing profiles if you want to. There's definitely a full section of code here at 1011.551 if you want to. I wouldn't do that necessarily if you're doing just basic egress stairs, whatnot. Something I also wanted to add is that risers shall be solid, and it's very blatantly said here. You can see at this code excerpt, literally right there, risers shall be solid. This is very obvious. So just kind of know every stair has to be, but there are exceptions. I always feel interesting that there are more exceptions than specifics, but obviously here are the exceptions. Solid risers are not required for stairways that are not required to comply with section 1009.3. And that is basically, is the stair an accessible stair or not? Provided that the opening between the treads does not permit the passage of a sphere with a diameter of 4 inches. So this is the same code that we're used to seeing with the guardrail. That's what we're used to. So basically, what is this saying? Well, this is saying if you have a stair that is considered to be an egress stair and an accessible means of egress, 1009.3, then you're going to have to close your risers at all. Completely. So basically, if you're using a stair to egress, it needs to be 100% closed stair, no open risers, that type of thing. So where are you going to see most of these open risers? Well, you're going to find them mostly for residential, obviously. And then obviously we can look down here and see spiral stairs. Of course, we'll get to those codes in another video. But that's kind of the basics of risers in general. If it's considered a convenient stair, which means it's not a part of a means of egress, or therefore is probably not also an accessible means of egress, then you can have open risers. So a lot of these monumental stairs that you see have open risers because of that reason. So also something to be aware of. And then finally, we move in beyond the actual stair components diagram to a minimum of 6'8" or 80 inches of headroom required. And obviously you need to maintain this throughout the entire length of the stair, because the whole point is to egress, and you can't have a certain point that dips below 80 inches, because that's going to be a headache problem for not everyone, but a good handful of people, enough to where this is an actual worry. So here's a diagram that's going to show that. And you can see here that we have our continuous 6'8" or 80 inches along the entire stair run. So a couple of things that I want to draw your attention to is this plane of tread nosing. And then it's basically an imaginary line drawn between all of the nosings of all the treads. And note that that does continue to the floor at the base of the stair run. And you can see also that our tread length D is calculated beyond the last tread at the bottom of the stair, because again, that plane of tread nosing extends to that point. So you extend from that point all the way up to this point here, to where you would have to have at least 6'8" or 80 inches. And we can see that is maintained right there. And obviously the same thing at the top, but it's a little easier because the top actually is the top nosing of the stair. So those things are very important. And obviously as your tread depth increases for whatever reason, so will this. This will have to increase as well. Alrighty, then the minimum stair width, and I know we're not talking about calculating stair width, but we're talking about specific minimums that you have to maintain for this to be called an egress stair. So we have a minimum stair width of 44 inches, and that assumes that you have greater than 50 occupants in your building. Likewise, if we have, for some reason, less than 50 occupants, then we can have a minimum of 36 inches. And that typically is measured between handrails. Now, also note with this in particular, that we're talking about not always considered accessible stairs. So that's not always going to be a accessible stair, but we will get to that in just a second. So here's a diagram, and this is a portion of the code book, and it's explaining our width and capacity. Here we need not less than 44 inches, and we have some exceptions here that pertain mainly to residential, and then here we have our less than 50. We can have 36 inches. Cool, easy enough. So we start to throw wrenches into things when we think about accessibility, and now we always have to do that. So typically you're going to have to also look at section 1009, which is going to be the means of egress, but also the accessibility, like an accessible means of egress. And so looking at that, we can see a minimum stair width of 48 inches between handrails unless equipped with an automatic sprinkler system. Okay, we're probably used to using those if you're working in a commercial building. If not, then that's the case. So looking at this diagram, again, we've got another spec section, which is 1009.3.2. This is going to say, yeah, you're going to need the 48 inches regardless, but I will point you to the exceptions, because that is looking at not, and therefore reducing, the width of 48 inches down to something else. Now, it doesn't tell you what that is, but I'll tell you it's going to be 44 inches no matter what. And so the clear width of 48 inches between handrails is not required in buildings with an automatic sprinkler system. We talked about that already. And then here we go. The clear width of 48 inches between handrails is not required for stairways access from a refuge area in conjunction with the horizontal exit. What does that mean? Well, imagine you have a stair egress that dumps on a level 1, or you have a just horizontal exit. Then that's where you would likely locate your area refuge. And if that's the case, you don't need all of that width, and you can go down to the 44 inches. So this, the main thing I can tell you about stair width without actually getting into calculating it is that it does matter whether or not the stair is considered accessible. That's one. And then two, do you have an automatic sprinkler system? Typically, if you have an automatic sprinkler system, it's going to be an accessible stair and things like that. So you'll be able to go down to the 44 inches minimum. Now, obviously that takes calculations. That does not take any calculations into account, because that has everything to do with occupant load. We're not talking about occupant load. We will talk about that later. Okay. And then finally, moving down to railings. I will have a separate video on railings for stair codes in particular, because that matters a lot. It has a lot to do with, it's totally separate, and I want to keep it separate except this one thing, and that is railings cannot project more than 4.5 inches into a stairway. All right, yeah, this is a large section, but that's okay. And basically what this is saying is that we are typically going to calculate our stair width between the handrails. Now, if assuming we have the 4.5 inches, if we're not exceeding the 4.5 inch projection of handrails, then you can take that calculation based on the actual, let's call it occupiable area of a stair. And now let's go to Revit, and I can show you where that might actually be. So here we go. I've actually turned the handrails off here, and we can see that we can occupy this entire tread. And that is assuming that our handrails do not exceed the 4.5 inches. Now, if that's the case, if you for some reason have to have handrails that exceed the 4.5 inches maximum, then you're just going to have to increase the width of your stair to maintain the distance between the handrails, that type of thing. And typically that's because you want the 48 inches in a non-sprinkler building and all this, because that would be enough to allow a couple of guys to carry let's call it a person down the stairs on a gurney or whatnot. So you have enough distance between the handrails to do that. So automatic sprinklers and all that do account for that being able to be different, which is totally fine. And so with that is like the super basics of stair code. So this is going to get you, let's say, 95% of the way. Now, this does not account for specific residential circumstances. It does not account for all of those super one-off things that you're going to have to check on yourself, but this will get you 90% of the way there, especially if you're doing a real basic commercial project that requires a stair for egress, which I would imagine most do if they're more than one level, that type of thing. Okay, so what I want to do now is actually go into Revit and show you a couple of things with stairs. So obviously what we know is that this is out of the box. We have a 7-inch max riser and 11-inch tread. We are very used to seeing this because it's code. Do note, and here's going to be the main theme of what we're talking about with stair codes and Revit, is that you can change everything. You can break these stairs, and so they're not in code in 1 second. Like, it takes nothing. And so the thing to be aware of is that Revit does not care about what code is. There are a few things that it kind of helps you along the way, in that, in this case, the out-of-the-box stair is a 7-inch max riser and 11-inch tread, which is totally what we're used to doing in most commercial conditions. So just know, again, the minimum width is already probably wrong. Yeah, this is right in a sense that you're not going to have one that's less than that unless you have a specific residential condition. But just know that you're going to probably need something more than 36 inches between the handrails or a clear width, that type of thing. So I would be changing this all day long, maybe not in the stair type, but as an instance. So that type of a thing. Also, here's where you would change your nosing profile and your different landing types. I will say, just saying this right now, I have never needed to change any of this except for, let's say, these basic stringers from probably 2 inches to 1.5 inches, whatever you're more used to seeing and more used to using, that type of a thing. But really, most of this you won't want to mess with because you're more likely to get into trouble without knowing it, for one, but two, that this is a good starting point at least. This is at least to some sort of a minimum code. Now, the second we start to change some of these max riser heights and tread depths and change some of these stair calculations, then that's when you're going to find yourself getting into some trouble. And the unfortunate part is that you probably won't realize it until it's too late. And that's really unfortunate. So things to be aware of when it comes to that. So obviously we can change things here, but I want you to see here that the actual riser height is not going to hit the 7 inches. Obviously, if I have increments that allow it to hit 7 inches exactly, it will, but a lot of times it won't because of the number of risers won't hit that 7-inch increment perfectly when you have the base and the top into consideration, that type of a thing. So most of that's not going to be a worry for you. And the reason I keep the treads at 11 inches is because it's totally consistent. It's really easy to calculate, and that is what it is. So that is going to be the code for stairs. And this is mainly egress, mainly commercial. That's the last time I will say it, but we did look at everything that we could consider looking at for stairs in the future. We're going to look at rail codes because, there are less of those, but they're also very important. They play into the documentation of the stair, which we will get into after that, because it's important to not only be able to model the stair, which we have already looked at, but can we take the modeling to the point to where we feel good about it from a code standpoint, and then can we document that appropriately to get the stair built the way it needs to be built, that type of thing. So we're going to run through that entire process, and then finally at the end I'll make one video that will basically run through everything together as a summary of how to model it, document it, things like that. So stick around for the railing code video that will be coming out very soon, and then we'll look at all the documentation of stairs after that. Just know, again, this is general. Please look at your own situation, your own project, because things will differ. Maybe they won't, but chances are something will differ, hopefully in a good way for you. So again, that will do it for this video. I hope you enjoyed it. If you did, please demolish that like button. It tells me that you enjoyed it, but you might have also learned something, which is the whole point of this. Also, let me know what you think of the format. If you like the notes and diagrams or whatnot, I'll leave a link to that particular note, so you can always keep up with that in the description below. So be sure to check out that. And I will see you in the next video. Have a wonderful day, and thank you very much for watching.